Hello, friends. Have you ever wondered why electricity or shipping costs often change, even though the operations look the same? Apparently, this is caused by semi-variable or mixed costs. In this video, we will thoroughly discuss how to separate them using the least squares regression method. Let's get started. What are semi-variable costs? Semi-variable costs are costs that have two sides, fixed and variable. Fixed costs are like basic costs that must be paid, while variable costs will go up and down according to activity. For example, electricity in the office. There is a fixed cost, but the more computers are on, the higher the bill. The other examples of semi-variable costs are like electricity maintenance, telecommunications, shipping, and marketing. Why does it need to be separated? Because by knowing how much the fixed and variable components are, companies can make more accurate budget planning and cost analysis. Well, one of the most popular methods for this is least square regression. This method has advantages, namely, first, more accurate than the high-low cost estimation method. Second, can be used to predict future costs. Third, can be scientifically proven so that it is more reliable in financial analysis. However, while this method has its advantages, it also has its disadvantages, namely, first, assuming a linear relationship between costs and activities. If this relationship is not linear, the results can be wrong. Second, only considering numbers, not looking at other factors that can affect costs. Third, need accurate historical data. If the data is wrong or incomplete, the calculation can also be wrong. Next, we will learn how to separate costs using the least square regression method. How to separate fixed and variable costs. Separating costs using the least squares regression method typically involves analyzing a mixed cost structure, which includes both fixed and variable costs. The goal is to estimate the fixed and variable components of total costs based on historical data. Here's a step-by-step guide on how to do this. Step 1. Collect data. Gather historical data on costs and the level of activity. Example, units produced, worked hours, etc. You should have a data set that includes total costs, dependent variable Y, activity levels, independent variable X. Step 2. Organize the data. Create a table or spreadsheet with two columns. Column A, activity level, X. Column B, total costs, Y. Example, there are 4 products. In sequence, products 1, 2, 3, 4 have total goods of 100, 200, 300, and 400, 400. While the electricity, column B, is 90, 120, 160, and 200. Step 3. Calculate the least squares regression. You can use statistical software, a calculator, or Excel to perform the least squares regression. The regression equation will take the form y equals a plus bx, where y, total costs, a, intercept, estimated fixed costs, b, slope, estimated variable cost per unit, and x, activity level. Step 4. Calculate the value of x times y, and also x squared. Step 5. Now, insert those values into the simple linear regression formula. Let's begin with calculating b. The formula is n times the sum of x times y minus the sum of x times the sum of y. Then, divide that result by n times the sum of x squared minus the square of the sum of x. Next, we calculate a. The formula is the sum of y minus b times the sum of x. All of that divided by n. For further understanding, let's look at the following example problem. PTX wants to separate fixed and variable costs using machine hours, X, and maintenance costs, Y data for 6 months in order to improve budget accuracy. The first step is to calculate the total machine hours, total cost, total multiplication of X and Y, and total square of X. This data will be used to find a regression equation with the following formula, y equals a plus bx. This is the table that show the machine hours and the electricity that used during the 6 month. Put all the calculations in the auxiliary table. For example, for the first month, X equals 80, Y equals 1,220,000 rupiah. Then the value of xy equals 97,600,000 rupiah, derived from multiplying x and y, and x square is 6,400. Do this for all months and then add them up. So after doing the calculation, the result will be like the table below. Don't forget to add everything up after you're done multiplying and squaring. The second step is to calculate the slope, b. Slope, b, shows the variable cost per machine hour. Let's substitute the value into the following formula. To calculate the value of b, we use the formula for the slope of a linear regression line, which is b equals n times the sum of x times y, minus the sum of x times the sum of y, divided by n times the sum of x squared, minus the square of the sum of x. In this case, n represents the number of observations, which is 6 months. Now, substituting the values, b equals 6 times 2,290,600,000, minus 1,230 times 10,320,000, divided by 6 times 295,000, minus 1,230 squared. This gives b equals 1,050,000,000 divided by 262,500, which results in b equals 4,000. So, the slope of the regression line is 4,000. Then the final result is 4,000 rupiah per hour. This means that every additional machine hour increases the maintenance cost by 4,000 rupiah. This is the variable cost per unit. The third step is to calculate the intercept, A. Intercept A is the fixed cost. Let's substitute the value into the following formula. To find A, we subtract 4,000 times 1,230 from 10,320,000, then divide by 6. This gives A equals to 900,000. The final result is 900,000 rupiah. This means that the cost that must be paid per month apart from the use of the machine is 900,000 rupiah. After some calculations, the linear regression equation is obtained, namely y equals 900,000 plus 4,000x. With this formula, PTX can predict next month's electricity costs. For example, if the machine is used for 300 hours, y 900,000 plus 4,000x, y 900,000 plus 4,000 times 300, y 900,000 plus 1,200,000, y 2,100,000. Then substitute it into the equation, and the result is 2,100,000 rupiah. This prediction is very close to the real data. The small difference occurs because regression is an average line that minimizes error. Now you know how to separate fixed and variable costs using the least square regression method. This method is scientific, quite accurate, and very useful for financial planning. Don't forget to like, subscribe, and share this video if it's useful. See you in the next educational content. Thank you.